We're group 7 for this class. This is the UCF parking map project that we've done all semester. My name is Nicholas Plimpton, and the rest of my group mates will introduce themselves.
I'm Alexander Neal.
I am Brandon Clark.
And I'm Pablo Trevino.
And Alex is going to take it away for us.
All right, so here is our website. Click this image to agree and continue. Don't use it while driving. Don't use your phone while driving. Parking at UCF can be a nightmare at times. It'd be super helpful if when you leave your house, you know which garages are full, which are about to fill up, and which are empty. The purpose of this website is to provide a fast and easy way for students and faculty to know which garages are available to park. So before our website, the only alternative was the UCF parking website, which only displays how full garages are with numbers. Along with showing numbers, our website has a visual aid that lets you see how full garages are at a. Also, our website has some functionality the UCF parking website does not, such as showing which garage is closest to which building and drawing a route in Google Maps from a selected garage to a selected building. So you can see I put in garage B in the education complex, and there it is. The core feature is that our garages actually change color based on how full they are. Everything's kind of empty because of Corona, so this really messed with us. So right now we have it set to 7% is full, which is red, and 2% is yellow. But that's the core feature of our project, is that they change color based on how full they are. So you can see at a glance how, like, which garage is best for you to park in. So I'll pass it off to Nick now.
For the technologies used in this, we were originally planning on going with the Google API to connect the Google Maps links and everything, but as it turns out, we were kind of able to do it without that. So we didn't use the Google Maps API. We just linked to it. The second biggest technology we used was probably the SVG map, which I will show here, the functionality behind it. So SVG stands for Scalable Vector Graphic. It's basically just an image drawn with math instead of defining individual pixels, so that it scales and everything stays sharp as you move around and zoom and pan in the image. SVGs allow you to define the objects and everything. So, for instance, we can set the object ID of each thing individually. We can give it GPS coordinates in the description if we want to. We can, if I can find it, we can change the RGB values of the fill for each object, which allows us to insert code and change it dynamically relatively easily. So we use the SVG on the parking website here, as you can see. So that kind of allowed us to go through and make changes really easily. It allows us to identify things on the map for future expansions, potentially. What else did we use? We used Amazon Web Services for quite a bit of it. Pablo may talk about it a little bit, and I can pick up on that afterwards. So let's pass it off to Pablo next.
Our project uses several algorithms to function. So firstly, a website scraper written in Python takes information from this website. As you can see, the spaces available and the percent full, as well as the name of the garages, are listed. So after that information is taken, it's used to calculate the percent fullness and to color code each garage. Next, a JSON file containing the percentages and names of each garage, and a JavaScript file that assigns colors to the garages are generated. After that, the web scraper sends the information to our Amazon S3 bucket, and that function, which is kept in a Lambda function in Amazon AWS, is called every 10 minutes using CloudWatch. Another algorithm used is the go to Google Maps function, which builds a URL depending on what the user selects in this drop-down menu. So as you can see, if I select garage B and For example, the student union. By clicking go to Google Maps, it'll set the garage as the start point and the building as the end point. Another algorithm is used to determine the closest garages, which takes into account the distance of each garage and lists them out when a garage is picked from the drop-down menu. In the future, we hope to implement a few more functionalities. For example, we want to add a way to filter by parking permit. So a drop-down menu with a parking permit will be shown in the SVG, in the website, where upon clicking on it, the garages that accept that parking permit will show up on the SVG. We also want to add a peak hours, which Nick will talk about now.
So the peak hours seem to be like a real difficult issue here. I believe I speak for all of us when I say, we got a little over our heads in on this project with the fact that it's all live data that's constantly being updated and being stored, and we're all having to adapt to using like external services such as AWS to try and get things done. During our development of the popular hours portion of it, we actually ended up hitting our free tier usage limit, or whatever you want to call it, on Amazon Web Services. So we had to disable some of our scrapers dumping info into our storage bucket, so that we didn't end up getting charged for it. That being said, the popular hours feature was intended to take each garage, and when you click on the garage, it'll give you a bar graph. Actually, let me pull this up real quick. So I've got a picture somewhere of it. Stored it somewhere. I should have had this ready. I apologize. Maybe we'll not find it. Anyways, there's a popular hours graph that you would see on Google Maps for any business, and that was kind of meant to help the user determine what time they should get to the parking garage if they want to get there before it's full. Again, hopefully we can do this again in the future, or we can figure it out in the future as to getting the amount of information we're pulling in under a free tier usage limit. And yeah, I'm a little lost at this point. I'm just going to go ahead and pass it off to Brandon to cover the questions that anyone who would be watching this might have. After you, Brandon.
Okay, so some of the questions that we might get if we're showing this to people is most students and faculty already know where all of the garages are. So how does this even help? Well, for students, your classes change all the time, every single semester. And so if you've always had classes in like classroom building 1, classroom building 2, then all of a sudden you have to be all the way across campus, you might want to know which garage is closest. So you have to like change your schedule and everything. It also provides a quicker visual aid to know how full all the garages are instead of pulling up the website, looking at all the numbers about which garage has how many spots left, and you got to do a little bit of computation yourself there. One of the other questions we might get is how would we need to change the website if UCF adds, or which is probably more likely removes, a garage from campus? The first thing we would need to do is we'd need to update our SVG image, which Nick showed you. We'd have to outline it on our map and then also add a way to change the color for it. Then we would need to change the web scraper in Python so that it accounts for the new number of garages that UCF has. The final question that we might get is, why did we decide to use an SVG? Why couldn't we just embed a Google Maps image that would be interactive and we might be able to just show the routes on there? Well, the SVG is much easier to draw things on, which allows us to outline all the garages and label them, so that looks much nicer. And you can also zoom in on the SVG and everything stays scaled and it looks really nice. Whereas with Google Maps, we'd have to start dealing with their API. When we draw boxes, it's a little more complicated. Changing the color would be a lot more complicated. So overall, the SVG was just better for us. All right, so how do we want to end?
So yeah, I guess we'll cut it here. Thanks for an awesome semester, Professor. This class was dope. Anyone else want to say thank you?
Thank you.
Yeah, thanks.
Thank you for watching.
Have a good one.